Welcome to the AI for Career Success video overview by Curt Robbins, where we help you get smarter than your competition. Today, we're taking a deep dive into the perspective of Turing Award winner Yann LeCun, based on his interview in EP20 Yann LeCun on the Information Bottleneck YouTube channel. Now, in a world where large language models seem to be the undisputed kings of AI, LeCun poses a rather provocative question. What if this entire approach is a dead end? So let's start with that very stark warning directly from LeCun. While large language models are, everywhere in the artificial intelligence landscape, one of the field's most important architects is saying this. He's arguing that the industry's focus on text is fundamentally flawed and that it will simply never get us to true human-level intelligence. So why is he so convinced of this? Well, LeCun's entire critique really starts with a fundamental data problem, and that is the sheer poverty of text, especially when you compare it to the incredible richness of the physical world that we all live in and experience every day. He argues that if you could somehow gather all the text ever written on the entire internet, it would still be a surprisingly small amount of information compared to sensory data. Think of it this way. All that text might be a large book, but the sensory data a human experiences is an entire library. The difference in scale is just massive. And to put a concrete number on it, LeCun calculates that all the text data used to train one of these giant LLMs is informationally equivalent to only about 15,000 hours of video. Now, that might sound like a lot, but that's about the same amount of visual information a 4-year-old child absorbs just by observing the world around them. And this, right here, leads to a really critical limitation. According to LeCun, models that are trained only on text can never develop a truly grounded understanding of reality. I mean, they get incredibly good at manipulating symbols and predicting the next word in a sentence, but they just lack that intuitive grasp of physics, of causality, or the ability to plan actions within a real-world context. Okay, so if LLMs aren't the answer, then what does LeCun see as the path forward? For decades, he's been a champion for an alternative architecture, something he calls world models. Now, when you hear world model, it's easy to get the wrong idea. A very common misconception is that it has to be this pixel-perfect simulator of reality, almost like a hyper-realistic video game engine. But LeCun is very clear that this is not what he means at all. He clarifies that the real objective isn't to predict every single detail. Instead, a world model works by learning abstract representations. It figures out what's important and what's irrelevant, like ignoring the way leaves rustle in the wind, so it can predict future states in a way that's both efficient and actually useful for planning. And this central idea, the concept of making predictions within an abstract space rather than a concrete pixel-by-pixel one, well, that represents the fundamental technical innovation that LeCun is really proposing here. And you should know, this isn't some brand new idea he just came up with. LeCun has been working on this for a very long time, starting with concepts like Siamese networks way back in the 90s. This is really the culmination of decades of research, which is now taking the form of what are called Joint Embedding Predictive Architectures, or JEPAs. So, how does a JEPA actually work? Well, imagine you're watching a film. A JEPA doesn't try to predict what every single pixel on the screen will be in the next frame. That's a nearly impossible task. Instead, it encodes the scene into an abstract representation and then just tries to predict what that abstract representation will be like in the future. In other words, it's predicting the plot, not the exact camera angles, and that's really the key to making prediction manageable. LeCun argues that this architectural approach is absolutely essential. It's the only way for an AI to learn the foundational, common-sense knowledge about the world that humans and even animals seem to acquire so effortlessly. Just think about it for a second. Concepts like object permanence, knowing a ball still exists even after it rolls behind the sofa, that can't be truly understood just from reading text. An AI has to learn these things by observing and interacting with the world, and that's precisely what a world model is designed to do. And this leads to a pretty fascinating idea from LeCun. He posits that the hardest part of building AI isn't teaching it to write poetry or play complex games. He actually believes the real challenge is giving it the common sense of a house cat or a dog. Once we solve that problem, creating a system that truly understands the physical world, he suggests that adding higher-level reasoning is, believe it or not, the easier part. So this objective-driven architecture, it also offers what LeCun sees as a much more robust and sound path to AI safety. He frames it not as a problem of fine-tuning after the fact, but as a core engineering challenge from the very beginning. With LLMs, safety often feels like an add-on. doesn't it? It's a layer of guardrails that we apply after the model is trained, and these guardrails can often be bypassed or jailbroken. But in contrast, a world model system can be designed from the ground up to be intrinsically safe. Its core objective function can be engineered to maximize a goal while simultaneously satisfying hard safety constraints. Safety becomes part of its fundamental nature, not just a patch.
So LeCun's work really challenges the current paradigm in the industry. It forces all of us to ask a pretty critical question. Is our immense investment in scaling up language models taking us down the right path? Or is a fundamental shift, a shift toward understanding the physical world, what's required to make that next great leap in artificial intelligence?
Thank you for joining us for this AI for Career Success video overview. This is where we teach you AI and help you get smarter than your competition. If you like these videos, please use the QR code at the beginning or end of this video to buy us a coffee. We also encourage you to subscribe to the AI for Career Success YouTube channel. And please, like, comment, and share this overview. It really helps us reach a wider audience of professionals just like you.